Hi folks, welcome back to the 6.3 video series where we're practicing shell method and decision making. So let's take a look at question number 3. It says find the volume of the solid of revolution generated by rotating the area between the graph of f of x equals 2x minus x squared and the x-axis over the interval from 0 to 2. So let's sketch a graph for both cases, and let's talk about some decision making. So I know that f of x is 2x minus x squared, and I'm going to make the x-axis, in this case the other curve, the blue line, okay? Let's go ahead and sketch that. So 2x minus x squared. If I'm sketching this by hand, I want to notice that I can factor out an x and be left with 2 minus x. And what that means is that at x equals 0 and at x equals 2, I actually have x-intercept. Additionally, I know that this minus sign means that I have a downward facing parabola. Okay? So let's go ahead and sketch that. So I know that I cross at 0, I cross again at 2, and let's plug in the number 1 and see what happens. So 2 times 1 is 2, minus 1 squared will give us 1. So that means when the x value is 1, the y value is 1. And so what we end up with is just this part of the upside down parabola. Now the region is sealed off with this x-axis as sort of the bottom, okay? So now let's take a look at what our reflection or rotating around this y-axis will look like. All right. So if I'm revolving around the y-axis, then I will get this and this and this and end up with that. Okay. Now let's take a look at what's different in the around the x-axis diagram. So I have things that are the same. My orange curve is the same. My blue curve is the same. But this time my axis of revolution is, the x-axis, not the y-axis. And so when I think about drawing the reflection, I actually need to draw that down here, okay? So in the other videos, we were looking at problems where we approach the same problem in 2 different ways. But what we're doing here is we're actually solving 2 different problems, okay? So in this video, we're going to focus on the around the y-axis, and in the next video, we'll come back and look at the around the x-axis, all right? So our answer should not be the same for these 2. Okay, so around the y-axis. What happens if we draw, we want to use washer method, okay? So let's say that we want to use washer method. If we want washer method, then we need lines that are perpendicular to the axis of revolution. That would mean I would need to draw a line like this, okay? Now, if I wanted to use shell method, I would need to draw lines that are parallel to the axis of revolution. So that would mean I would draw a line kind of like this. All right, that purple line is parallel to the yellow line. Now, just looking at this, I already see that the washer method is going to cause me some issues because it goes from the orange curve to the orange curve. So I'm going to go ahead and say no washer method for this one. Okay, so let's get rid of that green line. But instead, I'm going to say let's use shell method because these purple lines all have the same top and bottom curve, okay? So the top curve is the orange and the bottom curve is the blue. All right, so let's set up our shell method here. So volume equals 2 pi, the integral from a to b of radius times height dx. Now I know it's dx because my radii are going out this way, and so that means I need dx. All right, that means I can fill in my bounds as 0 to 2. My radius is going to be the same as my last letter. Whoops. So radius will be the same as that. And so I will get x for my radius. And my height will be the top curve minus the bottom curve. Okay? So again, this is the top curve, and I'm subtracting, oh goodness, I'm subtracting the bottom curve. Okay, so let's simplify. 2 pi, the integral from 0 to 2 of 2x squared minus x cubed dx. All right, let's integrate. 2 pi times 2/3 x to the third minus 1/4 x to the fourth. And I'm plugging in 2 and I'm plugging in 0. So let's do a quick visual. Do I need to plug in 0? If I plug in 0 here, I'm going to get 0. If I plug in 0 here, I'm going to get 0. So really the only number I need to plug in is 2. So 2 over 8 times 2 over 3 times 2 cubed minus 1/4 times 2 to the fourth. This will give me 2 pi times 16 over 3 minus 16 over 4. So we've got a common denominator of 12. And so we can do 2 pi, 12 on the bottom, and we'll get 64 minus 48. And we'll get, let's reduce here to 6, and I get pi times 16 over 6, which gives me 8 pi over 3. Okay? So 8 pi over 3 is the volume of the shape that we get when we revolve it around the x-axis, or the y-axis, all right? So in the next video, we're going to talk about what happens when we revolve around the x-axis. All right, see you back here.